Here is a picture of 4 golden spires, if that will help remember 4 golden signals: saturation, errors, latency, and traffic. As I was saying before, I have not seen in an interview that they will specifically ask you for what are the 3 pillars, what are the 4 golden signals. The reason why I'm teaching it this way is because it's easy to teach this way. It's easy to be like, here are the 3 pillars, here are the 4 golden signals. And when you understand it that way, then when you're in an interview setting and they're asking questions that are a little bit more grounded in system design or understanding broader, more connected concepts. For example, if in an interview you were to be asked, okay, design a service, and then how would you perhaps monitor that service, or how would you make that service more reliable against any issues? You can think to yourself, okay, well, I do know that there are 4 golden signals, according to the Google SRE book, by the way, of monitoring. And if you can think of those signals, the interviewer doesn't need to hear those signals. They need to hear your solutions specific to that question. But these signals will help you generate those solutions. But let's talk about what these signals are, and then we can maybe try an example. So start with latency. Pretty straightforward, time taken to serve a request. But one thing to note about these signals is that it's not necessarily just one metric that we're thinking of. It's not like, okay, the latency picked up from a specific metric about a specific system call or HTTP request or something like that. That is an example of what you could measure to measure latency, but especially with complex services, or if you're talking about the user workflow across multiple services, the latency could be just how long it takes for after the user submits a request and it goes through all of your system and then returns. There's a lot of complexity in there, but the latency is still just a measure of how long did the user have to wait to get an answer. Or it could be as specific as between your service and a dependent service, what is the latency between the communication there, or the latency of finalizing a request, especially if it's a large data streaming type request. So that's how it could be broadly interpreted, but you also need to keep in mind that if there's an error, do you count the latency there? Because sometimes an error could happen fast or it could happen really, really slow. And so if you count that in your latency, for example, if you were to suddenly get a ton of errors, your service just goes down and there's immediate like 500 errors or 404 errors, something like that. Maybe your latency metrics would show that, hey, there's nothing wrong, latency is pretty low. But because there's so many errors, that's a little misleading. So you have to think about, okay, are errors going to factor into the latency? And if they do, then make sure you're also monitoring a different signal to ensure that you capture that failure state. And yes, white box, black box. There may have been some foundational material. If not, briefly though, white box versus black box. White box monitoring means that you can see how a system works and you know the internals of it. You can measure some of that stuff. Black box is you don't know how it works, or from the perspective of not knowing how it works. That's especially useful for your users do not know how your services work. They just know when they hit a button, how long does it take for the request to return or something like that. So that's the latency. That would be black box latency. White box is, okay, the authentication microservice, when it talks to the database and gets a response or whatever, what is the latency there of that particular gRPC request or something like that? That's white box. That's you knowing the implementation details of the service and specifically measuring that. It's good to have both, because if you only have white box, you might miss out on what the user is actually seeing. And if you only have black box, then obviously you miss out on where exactly something might be failing. So traffic. So this again can be interpreted broadly, but it's basically how much demand is being placed on your service. There can be some overlap with these signals, by the way, if you notice that, okay, well, a specific metric that might measure some of traffic, but also some of latency. Well, or some of the others we'll get to. But some examples here, like the queue size, the higher the queue, the more demand you have on the service. Concurrent users or throughput rate, especially if it's like a streaming service, how much throughput is the stream able to manage, or does it need to manage? And then how many people can use it at the same time, especially if it hopefully shouldn't be queuing and only would be queuing if traffic were especially high or demand on it were especially high. Let's see. And there was a quick question about white box monitoring. That is, for white box, trace ID is useful, and wondering if there are other ways to do it. So I would say yes, absolutely. The trace ID would be useful for the white box monitoring, because that is how you'd be able to connect how your different services, like a specific request, pass through them. So that's definitely, that definitely would be handy there. But of course, it depends on if you're tracking a request as it goes through a service, or if you're just interested in a specific interaction between two services, in which case the request ID wouldn't matter. Although I do see that you have your hand raised, so you can, Mehmet, go ahead.
Yeah, Daniel, quick question. Yeah, Daniel, in our company, we have the multiple teams. So, for example, their UI hit their middleware service and they hit our backend service. So we use the only trace ID to match the everything, end to end. I don't know, is there another way to do this? Trace ID on the headers of the calls. So is there another better way? Do you know?
So if I understand correctly, you're saying that in order to track requests, you have backend, you have front end.
Another middleware, yeah, we have multiple layers. Yep.
Okay. And when you say, is there another way? Is there a different way to do this?
Maybe better way. I'm trying to understand best practices. Yeah, because sometimes some things fail at the middle, so they provide us the trace ID. With trace ID, and we are able to match it, the request from source to end, and our end to start point.
Well, I guess it depends on the kind of failure. So is this a failure like a request specifically failed, or is this the service is unhealthy and the service is failing? Because depending on which one it is, it will matter more. Like obviously a request ID would be useless if one of those middle services is just straight up down, in which case any request it gets, or most requests, it would be failing. Even
it is successful, sometimes it's not behaving, as expected, For example, say they send some payload with something, they expect, for example, write 200 requests or something, but it's returned sometimes 400. So, so it is, error different from the error, even it's successful, but they are getting the different response than expected. So,
yeah, this is actually, I have a slide for this. I'm not sure where it is in the presentation, but I can briefly say that, the different types of errors are things you should watch out for. Like there's obvious errors that are just, okay, it returned, there's 500 or something like that.
I know it's very important, right? There are discussions.
And that's those kinds of errors are easy, but then when it's kind of, it's on the slide. I forgot the name because it's just trivia, but
I will ask. I get it. Yeah.
But yeah, there's a kind of error where it returns the wrong information, even though it on the surface is a successful result. And the only way to kind of protect against that is data quality testing, integration testing, just tests that will go a little bit further than simply monitoring an error metric. And so it's a little bit more involved to capture that kind of.
I will ask question. I can ask that time. For example, if something is successful, but we need to return something negative, right? Should we return 200 or 400? But I can ask question. When you get there. Thank you.
All right, sounds good. Yeah. Let's see. So. And a quick question. So I know that Umberto wants to make sure that their name shows up correctly. I have been told by operations that if you, I think that up level must be the platform. So I don't have tons of knowledge myself about the up level platform, but it sounds like you can reach out to the support team on up level, and that might be a better way to get operational support for questions like that. But yeah,
I
just
think IT operation, right? You need to write IT operation in the chat or someone, yeah.
Yeah, but they said they don't actively monitor the chats, so maybe somebody will see it, but reaching out to support on the up level platform looks like that's the way that they recommend. Even though the video did say, I think, reaching out on the chat, but yeah, so it doesn't hurt to do both, obviously. But yeah, just FYI, just to make sure that any technical questions do get answered there. But let's see. So, but yeah, traffic. So yeah, we covered traffic errors. Oh yes, this is the slide. So this is what we were just talking about, in fact. So very relevant to the discussion here. The rate of failed requests, but there are different types, and the complete failures is the obvious one. The like, oh, there's a 500 or timed out, or just it just failed. Implicit failures is the one where instead of returning 200 results, it returns 400. So yeah, that is the kind of failure there, implicit failure. And yes, protecting against implicit failures, that is a more difficult story. Because obviously it depends on the service, but the implicit failure in this case, integration tests, so testing endpoints and end-to-end tests, stuff like that, doing that before release as much as possible is usually the best way to try to capture as many of these as possible, because once it's out in the wild, and if you do have like, at Faang scale, you'll have millions of requests, or at least thousands of requests. You'll have just tons and tons of volume of traffic, and you won't be able to carefully pick through each individual request trying to see what went wrong or something like that. You'll have to gather information at scale. And so if you mentioned, for example, 200 results or 400 results instead of 200. And in that case, if there is a metric, if that's something that happens a lot, like if it's okay, we really are getting this issue where the incorrect number of results are being returned, possibly create a metric on the number of results.
Yes, sorry. I try to get let me be more specific. So, for example, we have a get customer call, right? I send a customer number. So, if the customer not exists in database, right, not found. But this is not the right. It's not found. Mean there is no customer, but the call is successful. They can hit our backend. So, actually, I typed in the chat. So my question is, I think 200 is the better way, right? 200, but with a message, No, there is no customer with that customer ID, or because 400 is a kind of error message, right? Because what do you think? Yeah, maybe you can give.
So I would say this sounds maybe a little, especially I noticed your question of like, okay, no result exists. Should it return 200 or 400? And I think that definitely, as far as HTTP conventions, the 404 not found is a specific code for something that's not found. But you are thinking very much specifically about implementation details, which may or may not matter so much. Like if your services operate very much on this framework of these different codes, and if your services are at the level where these codes are meaningful at the service level, at the implementation level, then absolutely pick the code that works with your service, because the purpose of that is to inform both your services and optionally the humans monitoring them. However, depending on what services or what scale the company you happen to work for is, It's not always, it doesn't always come down to whether it's a 200 or a 400 error.
Because
Sometimes it could just be that the service
yeah,
is designed to return an error response of some
I
kind.
have a question here. Our production team sometimes mistakenly they report us. There are many 400 results. So they are asking us, is there any, service failure or something is down? Actually, nothing is down. Everything is okay. But, if nobody knows the expected contract, they may think, system has some issue, right? Because constantly getting 400 error, right? So this is the maybe side effect. So otherwise, yep, you're right.
Yeah, there's and we won't be able to like fully go into this, so we'll have to move on. But it sounds like there definitely, if you are using codes, if your services and your company does assign a lot of meaning to these codes, it is important to understand kind of what each code means. For example, a 400 level codes imply that the user did something wrong and they shouldn't try that again. So like if you get a 400 level error, that means that, okay, whatever I did was wrong, whether it was forbidden, I don't have access, or is not found, I shouldn't look for it there, or something like that. That means the user needs to change their behavior. 500 errors are appropriate for when, okay, on the service side, we did something wrong. We messed up somewhere. It wasn't your fault, it was our fault. And so that distinction is important there. So depending on whose fault it is that something went wrong, that's whether it's a 400 level or a 500 level. And then obviously if everything went right, then a 200 level, and then the other codes just use accordingly. So, but yeah,
got it.
Won't be able
Thank
to,
you.
But yeah. So hopefully that answered that question. But yeah, that is okay. Let's see. I think that we did answer most of these questions. Yep. Yeah, but that's the way that I have understood it the best, is that the 400 level errors, whatever they are, they always mean that, okay, it's on the user, it's on the client side, that like they did something wrong. Their request was malformed. They're looking for something that isn't there. They're not authorized, whatever. 500 level errors. Okay, that's our fault. Our server's broke. We did something wrong. The last type of error there, policy failures. This is also a non-obvious type of error, but this one is when we'll get into SLAs in pretty soon here. But a policy failure is when, even though it returned the proper result successfully, it did so out of some kind of contractual boundary. For example, if you have an SLA that, okay, when I make a request, or I expect to get a response within a certain time limit, or the latency is expected to be within a certain time frame, and that is passed. Again, latency could mean a lot of things, not just I send an HTTP request and I get the response. It doesn't have to be that. It could also be, okay, I submitted this report, this form to your service, and your services should process that maybe over the period of even a few hours. And if contractually you say it should be done in 4 hours, but you're done in 5 hours, that would be a policy failure. Even though you finished successfully, policy failure, you were outside of the SLA. So, but yeah, that is the error signal, the last signal. This one is probably the hardest to, it's a little bit difficult to wrap your head around. I did have trouble with it myself, but it's how fully utilized the system is. This can overlap a little bit with traffic, how much demand is being placed on a system. But this differs in that to answer how to monitor the saturation, you need to know what the bottlenecks of your system are. You need to understand what resources is it constrained on first. If you pushed it to the max, if you decided, okay, let's take this service that's doing its job, and what if thousands or tens of thousands or millions of people suddenly had to use that service, what would fail first? Would it run out of CPU? Would it run out of memory and crash? Would the network get too saturated and it would just start dropping requests? What's going to fail first if we push the service to its max? This is an important concept for thinking about interviewing at Faang companies, especially if most of your experience comes from a relatively small company or a company that with services that don't receive tons of traffic or just only traffic internally from the company itself. I've talked to some people worked at like a science or research labs, and they worked on services that were only used internally. And I said to them, okay, now think about if this service had to be used by just millions of people. What would fail first? What would you have to scale first? And that's what gets you into saturation. So if your service, if you know that, okay, we would run out of memory well before we would max out the CPU, then memory in that case would be a good metric to measure for saturation. But that's not always the case. Sometimes virtual machines can take up a lot of memory, but because it's a virtual machine, it can just be allocating within that memory that from the host level, it already has allocated from the system. So that's why, okay, sometimes it could be consuming 90% of a system's memory, but actually be fine and nowhere near toppling over just because of the way that the virtual machines work or the way that it's using the memory is just most efficient by using so much. Maybe the service works better when it consumes as much memory as possible without actually ooming or crashing the system or thrashing or anything like that. On the other hand, if you know that we're constrained on disk, then disk or CPU or something like that, those are things that you want to know so that you can measure that. That tells you what needs to scale first. Now, obviously, at some point, if you fix one bottleneck, another bottleneck will immediately appear. So that's not to say that other resources will never be a bottleneck if one is the current bottleneck. But that's how you think about saturation. It depends. It depends on what the service consumes the most of and what will break first. So those are the 4 golden signals. And again, these come from the Google SRE book, which is a useful resource. And I'll make sure to link that book. It's free online, so easy enough to find, even if you just Google it. But the Google SRE book is kind of fairly the fundamental standard for how SRE is defined. Google really did shape that role quite a bit. So that's, but again, with these 4 signals, you'll be at least decently covered. So we teach the 4 signals. You might not be asked, what are the 4 signals in an interview? Like, I doubt you'd ever be asked, because once again, in an interview, they might ask you to design a service. They might ask you how you would, in completing that design, how much you might monitor the service, or maybe if you're troubleshooting a service, you think about what you could expect to be monitoring from that service. And then if you know the 4 golden signals, you can think, okay, well, let's think about this service from terms of traffic. How do we know how much demand is being placed on it? What metrics can we expect there? What about saturation? What resource will be the first bottleneck with this service? Sometimes the interviewer, if they are asking you to troubleshoot a service, and this is kind of a discussion-based thing, then they ought to be able to also tell you what kinds of traffic patterns it sees, perhaps, or what resources is it constrained on, and then what errors are you seeing as well, and then the latency, and what latency actually means for that service. If it's a simple web server, then latency between hitting that web server. But if it's a more complex, like services I worked on in data ingestion at Facebook, then latency can mean something else entirely.